Hi everyone, welcome back to the channel. In today's video, we're going to look at how you can describe a discontinuous function in terms of the Heaviside function. And in today's video, I'm also going to try something different. My background for my canvas is going to be black and the writing is going to be white. I just want to see whether or not you prefer that. Me personally, it's easier on my eyes. So please leave in the comments below whether or not you like the black background or the white background. So let's get to it. So if you are given a discontinuous function, right? You're given this discontinuous function here. We want to find the description of this discontinuous function in terms of the Heaviside function. So these two are the Heaviside function. In a previous video, we did it the other way. We were given the function in terms of the Heaviside, and we then found out how to graph and how to find the discontinuous function, which is this f of t here. And we'll put a link in the description box below for you if you haven't seen that video yet. So if your discontinuous function is defined as f at 1t, where t is between a and b, otherwise 0, then the Heaviside function is going to look like this. Right? So we have f1t times u of t minus a minus u of t minus b. So you'll see here your discontinuity, you only have one discontinuity effectively, and it's happening at b. Right? There's a switch at b. What happens if you've got more than one function in your discontinuity, or more than one step in the discontinuity? So if you have, for example, your function f of t equals to f1 between 0 and a, equals to f2 between a and b, and equals to f3 where t is bigger than b, you can convert this into the Heaviside form. So we can then say, then t is going to be equal to, we look at the first part of the discontinuity, f1t, and it's going to be where it's t minus 0 minus u of t minus a. Right? And the way we describe it is the bottom limit goes here and the upper limit goes there. Then the next part of the function is going to be, that should be a plus, f2 at t, and your Heaviside function is going to be u at, the bottom limit is a, so it's t minus a, right, minus u at t minus b. Okay, then I'm just going to add in, you've got a third part for this function anyway. Each function is going to be different depending on how it's defined. U at t minus b, right? There is no upper limit here, right? Because t is bigger than b. So this is going to be the definition, or this discontinuous function in terms of the Heaviside function, right? In terms of that Heaviside function there. Okay, so let's do an example. We have f at t, and we have two possibilities and 3. So this first one is between 0 and 2, and the second part is bigger than 2. So then, if we write it in terms of the Heaviside function, we have f of t equals, f1 in this case is going to be t squared, and it's going to be u t minus 0 minus u at t minus 2 plus 3 at u of t minus 2. Okay? Then if we simplify, you're going to get squared. That is just going to be u at t minus 2, 3 u at t minus 2. And then I can say that t squared u at t minus t squared u of t minus 2, 3u at t minus 2. Okay? This first term here, you can just write that as t squared. Right? Just write that a bit better. So the first term you can just write as t squared. And the reason for that is the definition of u of t. Right? So if I take this piece u of t here, let's move that up for you. Right? So you see here, I've taken the first term and I've just said t squared. And it's because of the definition of u of t. So if I take u of t minus 0, right, that would be equal to either 1, either 0 or 1. So t, where t is smaller than 0 and t is greater than 0, right? But by the very definition of what t is time, right? So you're not going to get negative time. So this here doesn't hold, right? You're never going to get t less than 0. So it means that u of t is always going to be 1. That means that this piece here, that u of t is always going to be 1. We've taken our discontinuous function, defined here, right, into from two pieces, two parts to this function, and we have converted it into the Heaviside function, f of t there. And the advantage of this Heaviside function is that we can now take the Laplace transform of that function. And we're going to be doing that in an upcoming video. Well, I hope you found this video useful. Again, please let me know whether or not you prefer the white background or the black background in the comments. Also, if you've got any suggestions for me or any comments on the video, please let me know below. I always like hearing from you. Well, I'll see you next time. Bye.